Okay guys, so this is the video that I was promising you over a little bit more of completing the square, and then I also got a request to go over the word problems that are on the review. But before I get into that, let me again share with you that follow the lap in detail with these I can statements, and like I said, these little areas here, are to check off the things that that you can do and accomplish. So just make sure that in each section you read it, you understand what it's asking, and then also check off, I'm good on that, I'm good on that. And then again, use these page numbers and those appropriate problems to sit back and help you do that, okay? Then there's also something else I have not talked about, but this rating here, you could sit back, and again, this is helping you to prepare for the exam on Tuesday. There are these levels right here at the top. So again, it's important that when you get resources from any teacher, especially, let's just say, someone who's giving you this kind of rating scale and guidance tool, please use it. Okay, so you have these levels 1, 2, 3, 4. Like level 3 would be, I understand the assignment, I can get mostly correct solutions. I feel like a lot of us are here between level 3. I have plenty of successful people at level 4. And then I have people that fall kind of in between 2 and 3. So again, get to level 3 understanding. If you're at level 4, you should feel comfortable and not be stressed and ready for the test. And again, do this throughout the remainder of all of the year. Okay, so again, you can rate yourself in each of these sections, like, hey, I feel like a 2 here, a 3 here. I will move into probably the next lap that these are going to be for a grade, just to see that you're using them, or some additional type of points in some kind of way, and that you fill this out before you take a test. So we may think about that. So again, I have also posted all the solutions for these textbook assignments. It's in the email that I sent out on yesterday, so please check your email. And I gave all the solutions for all of these problems, literally like 98% of them. So you should be able to check yourself now and then bring those in on Tuesday so I can check it off as a homework grade. So please use the lab to help you. Again, this video mainly is going to be about completing the square, a couple of more examples of that, and then the 2 word problems that are on the review. So let's jump into it. Okay, so I'm going to start with the word problems. And again, you do have in another email the solutions to this review. Okay, so we're going to focus on, I think everyone is really good with number 13, so I'm not going to spend any time on that one. You basically just plug in the velocity, and then here's the initial height of the tower. The initial height is this h naught, that 80 feet per second is v naught, and you plug in those or substitute in those values, make a quadratic. Remember that when a is negative, it's a downward parabola, which means you have basically a maximum point at your vertex. All right, so this one is pretty straightforward. So I'm going to spend this time now on number 11 and number 12. Okay, so let's look at number 11 while this opens up. Okay, number 11, I'm going to read the problem. The dimensions of the old stage at this concert hall were 30 feet by 15. So if I'm thinking of a stage, I'm going to draw some kind of rectangle. Okay, whoops. I got this rectangle. It's this old stage. And again, it sounds like when you read that again, the dimensions of an old stage at the concert hall were, past tense, 30 by 15. So I'm going to make 30 feet be the length. And then, of course, the 15 feet be the vertical side, which is the width. Okay, so again, I read the next sentence. The new stage has a total of 1,000 feet. So far, if we just think kind of logically, if I do 30 times 15, that's going to give me 450, right? We agree on that? So I'm just going to do the math real quick on this. 150, 0, 0, and then 3. So we have 450 feet squared is this area here. So now when I read the next statement, it's saying that the new stage, they want to basically expand or make this larger, has a total of 1,000 square feet. So that means that somewhere around here, we have this new stage. Again, I know this is pretty large, but this is supposed to be a total of 1,000. Okay, and the question is, the dimensions of the new stage were created by adding the same distance to each side of the stage. What is the value of x? So that means that if the same value is added in all directions, Well, this was 1x, this is 1x, this is 1x, and then here is 1x. So I'm going to read that one more time. The dimensions of the new stage were created by adding the same distance x to each side of the old stage. Remember, this is the old part, and then the new. Okay, we know the new is a total of 1,000, and since it's a rectangle, right? So new is equal to 1,000 feet squared. And we know that for a rectangle, right, the area, I'm going to put rectangle area, is length times width. Okay, so basically what I'm telling myself at this point, okay, let me change that R to, I should use a different denotation. Like, it should be an A here. So I'll just put A rectangle is length times width. So basically, when I think about this length, which is 30 feet long, and if I think that I just add 1x here and 1x here, well, 1x plus 1x is 2x. So far for the area of the new stage, I have this 30 feet initially plus 2x, which again is these additional pieces here and here on the left and right side. So that gives me 30 plus 2x. And again, I'm going to represent that as my L. Then I have times, well, now I have the width, which is this 15 feet. And again, here's that 1x and this 1x. So I have 15 was my initial, plus these two additional widths, okay, on both sides of the old stage because we're expanding. So this is W. And then that's pretty much it. And they already told us that A new is the 1,000 feet squared. And we're just going to solve for x. So putting this all together, I have 1,000 feet squared is equal to, now I'm going to go ahead and FOIL out these two binomials. So I told you, so I did the math earlier. My first two terms, this guy and this guy. So I'm doing 30 times 15 is 450. Now I'm doing the outer, so this guy and this guy, that's going to give me 60x. Then I'm doing my inner here and here. There's 30x. Okay, and then I'm going to do my last two terms, which is here and out here, plus 4x squared. And like I said before, the outer and inner terms can be combined. Okay, so these two guys here come together. And I'm going to rewrite everything from left to right. 50 feet squared equals 450 plus 90x plus 4x squared. Okay, so I hope that, again, the setup makes sense. Let me kind of shrink this down so you see everything. I'm going to move up now. All right, so 90% of the time, to solve a quadratic, of course, we do want to make it look in standard form. So what that means is I'm going to take this value here that's on the left and just move it in, okay, to the right side of the equal sign so I can set this equal to 0. So let's subtract 1,000. Subtract 1,000 from that constant. This now will become 0 equals, and I'm just going to write this in the ax squared plus bx plus c form. So I'm going to put my 4x squared here, put the 90x there, and then if I do 450 minus the 1,000, I'm going to get negative 550. All right, sorry about this. This was a whole problem. All right, so now as you can see, I don't know what all is down here. Bunch of stuff I gotta erase. Okay, so now we have this in quadratic form, and here's the beauty of this. Now remember, like I've said a lot of times, I'm gonna say it again. When you have a quadratic, the ways that you can solve it is you can factor. That's the fastest way. The second way is, if it's not factorable, then you're going to complete the square. And then the last sure way, which takes a little bit longer, which is fine, but it's safe, is the quadratic formula. So at this point, because we're looking for x, which of course solving for x gives you your roots or your x-intercepts, right? Your solutions to your equation. You can use whichever one you want. In this case, on the answer key, from what I see, they're basically just factored. And everybody has different ways of factoring. I'm going to use the quadratic formula real quick, just to kind of change it up. So we got x is equal to negative b plus minus square root b squared minus 4ac all divided by 2a. Again, right here, my a is 4, my b is 90, my c is negative 550. I got my calculator, so let's see. So I got x is equal to negative 90 plus minus square root. 90 squared, I think that's 3,000. No, I'm sorry, 8,100. 8,100 minus 4ac. We're just going to keep running with that. And then 2 times 4. I'm just going to write this out here. And I told you I like to put my b squared. I'm going to open up my calculator real quick. I like to put my b squared, and then I like to do this little part right here, which is the 4 times 4 times negative 550. So I'm going to open up my calculator. Okay, here we go. So I'm going to say close to this, clear this out. Let's do 4 times 4 times negative 550. So I get basically that negative 8,800, but I want to go back real quick, make sure I have the right numbers. Yeah, 4. Yeah, so negative 8,800 here. And just to double check, because I did off the top of my head, I'm going to do the 90 squared. And yes, it's 8,100. Okay, so we're good. So now we're going to end up adding these two values together. So let's take the 8,100 plus the 8,800. Whoops, messed that up. Second answer. Okay. All right, and again, let me finish this off. Divided by 8. And move over here, equal negative 90 plus minus the square root. I believe I saw 16,900. Let me see. Yeah, 16,900, which is really interesting because if you know that 169, the square root of that is 13. So I bet you this one's going to be something like, I don't know, 1,300 maybe. We'll see. 16900. Okay. So negative 90 plus minus. So let's go ahead and take the square root. Whoops. The square root of second answer. Whoops. Square root. Yeah, it was 130. Oh, that 1,300, really, Lakeisha. 130. So this is 130. Time here. And then 8. Alright, so here's our two solutions. We got negative 90 plus 130 over 8. That's one answer. And then the other one is negative 90 minus 130 over 8. And you know that one's going to give you a negative value, so we definitely don't want that one. So we're looking for a distance. Okay, so this is the guy I don't want. So let's look at this guy. So if I do, 130 minus that, it's 40 over 8. And that's going to be 5. 5 feet. And that's it. So the final answer to this one, again, I do understand that in the solution, when I stared at it for a second, they did factoring. You're more than welcome to do whatever you want. I just did complete the square, just so it kind of throws in a different skill. And again, you wanted the positive answer. So it's 5 feet in all directions around the old stage to get that total area of 1,000, right? So I hope that makes sense. So now let's move to, I'm going to clear the canvas. Let's move to number 12. Okay. For number 12, let me go back to the page. Yeah. So this one right here, x is equal to 5 feet. All right. Number 12 says Faye has a picture frame. And so when you hear picture frame, you got to think this is the total amount of dimensions or area that she has. So she has 10 inches by 12 inches is this total picture frame. It says she wants to cut a border to fit the frame so that the border is the same width all the way around, and that there's an area left open for this photo that basically is 36 square inches. So the area inside is 36 inches squared. The total frame is the 120 inches squared. because I multiplied 10 times 12, and we want to figure out the length of this border. So let's go and draw a picture. That's what I've always tried to teach my younger kids, right? So we got this total picture frame, and it's 12 inches by 10 inches. You know, inside of this smaller area is 63 inches squared for the photo. Whoops, for the photo. Okay, and she wants the border to have the same distance or dimensions all the way around. So that's why I put X's. And so of course we know we're dealing with basically some kind of rectangle or a square, right? So I'm just going to go back and just think length times width, okay? So I'm going to say, you know, A length times width. And the question is, we're focusing on the border. All right, so when we look at this, A is equal to length times width. And now the interesting thing about this is, because this total frame is 120 inches squared, what I need you to understand is, and we have to, you know, put this border around, and then we have this photo inside of this inner area. You want to subtract away. So imagine, I'm just going to focus on the length and show you what I mean. So this total from here to here is 12 inches, right? That means if I want border, that means this part here and this part here, which is focusing on L, I got to take 2x away from 12. All right, because again, I know that this part right here, once I subtract away the 2 x's from 12, that's just going to leave me where the photo is. So that's why I want to be clear about this real quick. So we have 120. We got the 120 inches. Well, let me back up. Let's do the length and width. So the length is 12 minus the 2x. That's the L. Okay. Then the other part is the width. The total is 10 inches from here to here. So I'm subtracting away this x and this x to get to the photo. So for the width, I got 10 minus 2x. You see? So you take away, because I'm trying to account with those x's, the border that I need. How much of it do I need? All right. Now all of that, length times width, is going to equal, this is the part that's a little tricky, is not the 120. Okay. It's going to be the photo. Because again, since I'm basically going from right here to here is 12, right? Then I took this piece away and subtracted this piece away. Well, now that leaves me with the photo is the leftover. So everything is based off the photo. Same thing here with the width. We got the 10. We took away this x and this x. That leaves me back with the remaining pieces of the photo. So that's why we set this equal to 63 inches squared, which is the photo. Put that here. Because if you think about it, let's say backwards, it's photo plus the border is equal to what? The frame. If that makes sense, right? Okay. So now let's just see what we got going on here. So now let's do, first I'm going to foil this out, the stuff in the parentheses. So I got first, again I'm foiling, I got first, which is that's the 120, times outer, and that gives me a negative 24x. Then I have my inner, that's negative 20x. And then I have my last positive 4x squared, okay, equals to 63. Okay, now I'm going to combine these two, and I get 120 minus 44x. And then I have that 4x squared equal to 63. And again, I want to get it in standard form. So now I'm going to subtract away the 63 to both sides. And I'm going to rearrange this so it looks like it's in standard form. So 4x squared minus 44x. And if I subtract 120 minus 63, that's going to give me the 57. Okay. So now I got here plus 57 is equal to 0. And one more time, you can do this whichever way you want. Either you do factoring, or you could do quadratic formula, up to you. And in this case, they factored. So again, I'm going to show the way I factor. So the factors of this a term is 1 times 4, 2 times 2. The only way I can get 57, because it's a prime number, is 1 times 57. So I'm going to play with, let's see, I'm going to play with the 2 and 2. So I'm going to have 2x in the front, because when I multiply those first two together, that's 4x squared. And we just got to play with the placement of the 57. Well, it really won't matter actually, because I have a 2. So let me just do this real quick. Oh, wait a minute. There's 1 times 57. There. Wait a minute. This is divisible by 3, so there is one more factor, because I know 7 plus 5 is 12, and numbers that when you add them together, if they're a multiple of 3, they're divisible by 3. So let's do 3 divides into 57. Okay, I did have another factor. So 3 times 19. Yeah, because that 57 would make the 57 times 2 would be too large. So I'm glad I found this 19 and 3. So let's put 3 here, 19 there, and then let's do the FOIL method. So again, I got first, that's the 4x squared, and then 2 times 19, it's going to be, I believe, 38x, and then I got a 6x. And the good thing is, yes, 38 plus 6 is going to give me 44, and then 3 times, okay, yeah, so again, 38 plus 6 is 44, and then 3 times 9 is 57. 13 times 9 is 57. So this is good. These two added together will give me the 44x. So we're good. Now the problem is we want it to be negative, and I want to do addition. So these are both negative, and let's set it equal to 0. All right. Again, factor whatever way you feel comfortable. So now my two solutions are 1 of 2. We got to take the 2x minus 3, set that equal to 0. X is equal to 3 halves. Remember, we're talking about inches. And the other one is 2x minus 19 is equal to 0. Add 19. So then we got x is equal to 19 halves. Okay, inches. Alright, so these are our two possibilities. But, of course, we got to sit back and see which one makes the most sense, right? So if we change these to decimals, this is 1.5 inches. And if we change this one to a decimal, we get 8.5. 9.5. Yeah. Remainder of 1. This is 9.5 inches. And you just have to make sure it makes sense. So you got to go back logically and say, hey, if I was to make all my x's 9.5 inches in all directions, will it equal to the 63 inches square? Or, you know, will this all equal to, yeah, the 63 inches? You want to use this formula right here. But I'm just telling you that this one, it's too much. Okay, so you have to go back and think about it. That, hey, if I take 12 minus 2 times 1.5, right? Do that. And then you take the 10 minus 2 times 1.5. Does that equal 63? Okay, then you could also, like I said, double check with the 9.5. And like I said, this one is too much. Okay, so I hope that those two make sense. Just go back and replay them again. It all came back down to area of a rectangle, basically. Alright, so let me very quickly, just for a few minutes, let's go over completing the square. And the two cases that I really need you to focus on is what happens when a is equal to 1. There's one methodology, and then there's one when a is not equal to 1. Okay, so you have to keep those straight. So here's an example. Let me see if I can find one really fast, because I'm not sure, but I know that I think the second group, block 5, we got through both 23 and 24. So I don't know if I should rework those again or do different ones. Give me a second. I think what I'm going to do is let me just do some different ones. Okay, so let me do this. I'm going to go into the PowerPoint, which I think is 4.5. And there were some examples in here. So let's go down here. There's some notes on completing the square. Yeah, so let me go to that one, see how A is equal to 1 there, and it talks about imaginary roots or solutions. Then they have these two. Okay, so I'm going to focus on these two. Make sure one is not off the review. Okay, good. All right, so I'm going to do this one right here. Again, right here, A is equal to 1. So I'm going to go here and write x squared plus 6x plus 8 equals 0. Okay, so the first thing that you want to do, step 1, is subtract away your constant. Because again, when you stare at this, again, this is not factorable. And yes, as soon as you see that it's not factorable, you could do completing the square. But what we're going to do is, when you see that it's not factorable, you can go ahead and you can do the quadratic formula. But in this case, because they may specify complete the square, this is how you do it. All right, so we're going to subtract away the constant to both sides. Then we have x squared plus 6x. I make a little space. Here's negative 8. The second step after you, again, move constant to the right side of the equal sign. Very tired. Okay, we're going to half in this one. You half in the b. Okay, then after you half in it, you're going to take that value and square it. So here, I make this a 3. I square that, and I swing this up, add 9, and what I do to one side, I have to do to the other. Now, the part that I've tried to stress to you guys a lot is be really careful that you do not try to rewrite the statement as x squared plus 3x. No, leave that 6x there. So when we rewrite this, we're going to get x squared plus 6x plus 9, because now this becomes factorable, all right, equals to 1. And again, the left side's factorable, which becomes x plus 3 squared is equal to 1. And that's it. Now we're at the square root property, okay, where I want to, again, I'm solving for x. Square root property, we want to solve for x. So I'm going to take the square root of this side, square root of that side. This will cancel out. This falls out, and I get x, sorry guys, I get x plus 3 equals to plus minus, the square root of 1 is 1. Subtract 3, subtract 3. The answers are x is equal to negative 3 plus minus 1. So your two solutions are, x can be negative 3 plus 1, which is negative 2, or negative 3 minus 3, which is negative 4. Okay, and again, the beauty of solving for things is you can always go back and plug those two x values in to the original equation. Okay. But you know what's even better, can I be honest, is take the original problem, this one right here. God, that looks so blurry. Take the original problem, which was the x squared 6x plus 8, graph it in your calculator and see if your two x-intercepts are negative 2, 0, and negative 4, 0. Which I could do that for you real quick. Let's go here. Y equal. Clear this out. And what was it again? It was x squared. Whoops, just joking. Here, let's just do x and then you hit that one. Yeah, x squared, I think it was plus 6x plus 8. Then we're going to graph it. Okay, so you can't really tell, but I'm seeing something happen there at negative 2, and I'm also seeing that it kind of hugs, and I see some at negative 4. So let's go to the table, second table. And there it is if I scroll down. Do you see? Right there. There's one at negative 4, 0, and then look, negative 2, 0. So see, those are my two roots, or my two x-intercepts. All right, so that should make sense. All right, so that takes care of this one. Let's do it again, but let's do when a is not equal to 1. So here's a problem when our a value in standard form is not equal to 1. So I'm going to go back to the PowerPoint, and let's look at this one right here. So we got 2x squared plus 11x plus 15. Equals 0. Okay, so again, this is not factorable. Also, when they say a is not equal to 1, they're talking about this right here. So there are multiple ways to do this, actually 2 distinctive ways. In the textbook, they like to divide whatever's on the a. They divide every term by 2. You can do that. I factor out. It works out the same, okay? So look at the textbook. Also look at this example. I'll try to do one more because this video is getting kind of long. So in this case, what I'm going to do is I'm going to factor out a 2. But before I do that, what's the first step? Well, I go back up here and I say, oh, look, not factorable, move constant to right side. So the first thing to do is let's subtract away the 15. So move the 15 over. Now I have my 2 x terms isolated. Make a little space. Okay, there's the first step. Again, I want to make a equal 1. So to do that, I'm going to pull the 2 out. So I bring the 2 out. That leaves me with x squared, which again, there's the 1 I want. Now you have to think a little backwards because you're thinking about the distributive property. So 2 times what, you guys? 2 times what would give me 11x? Well, you just say, okay, 2 times some number needs to equal 11. So what do you know? The answer is 11 halves. So we put 11 over 2 here with an x. These 2's will cancel out, and see, that will basically leave me with, again, 2x squared, because I would distribute this to here for 2x squared. 2 times 11 halves, the 2's will cancel out and leave me with an 11. All right? So now, that's my b term. So now I'm going to take the b term, which is 11 halves, and I need to divide it by 2. Well, when you divide by 2, you're halvening something. So I'm going to multiply this by 1 over 2. Okay, I know I need to square that value, so I'm going to do a little math here. So this becomes 11 fourths, and I'm squaring it. So now when I do a fraction being squared, it's square the denominator and then square the numerator. I should have said that in different order, sorry. Square the numerator first, then square the denominator. So that's why right here, we're going to put 121 over 16. All right, and they know this looks really bad because of the fractions, but now this is factorable on the left side. So now let's talk about what's happening on the right side of the equal sign. Well, we still got the 15. Now here's the tricky part. We use another color. Since you added this 121 over 16, you have to keep in mind that you factored out a 2. So you got to do 2 times this C number. That's what you add to the other side. So here's your scratch work. You got 2 over 1 times 121 over 16. 121 over 16. And to do this math, I'm just going to reduce diagonally. So 2 divided by 2 is 1. 16 divided by 2 is 8. So I'm just telling you that over here I want to add 121 over 8. Okay, 121 over 8 is what I need to add on the right side. Okay, these are fractions. Put that over 1. All right, so now I'm going to move down. Let's clean this up. So I still have this 2. Now, we need to factor the thing in parentheses. The answer is, and I'm going to show you where you get this from. If you go back in the slides and you look carefully right here, and it says, hey, when I take b of x, bx, then I halfen the b amount, and I square it, right? But whatever this b over 2 is, whatever that is, that's what's the answer to make my factor. So let's go back here. When I halvened b, I got 11 fourths. So that means x plus 11 fourths squared. That's how you factor that. All right. And then over here, this is my scratch work for this. So I'm going to times 8 here, times 8 here. 15 times 8. Now I'll explain. This is 120. Okay, so now I have negative 120 over 8 plus 121 over 8. So that's why right here I get negative 1/8. No, positive 1/8. All right, so if you're confused by this part right here, I'm just saying, if you FOIL this out, it needs to look just like what was here in the parentheses. So I'm going to do this scratch work. So if I have x plus 11 fourths, I'm going to, again, FOIL this out. X times x is x squared. x times 11/4 is 11/4 x, inside 11/4 x, and last 121/16. And if we add these two together, we get x squared. We got our back term, so we got taken care of this and that. We need to get an 11/2. So guess what? If you add these two together, you get 22/4x. And if you simplify that, you see, divide them both by 2, you get 11/2. So again, with an x. So this is this term right there. So all three are accounted for when you factor it down to x plus 11/4. All right, we're good. Now, we still need to solve for x. So what I'm going to do first is, remember, the x is kind of captured inside of that parentheses really tight, okay? 11/4 is being added to it. It's a square. So the first thing we want to do, divide by 2. Okay, divide by 2 over here, which means I multiply by 1/2 over here. So now I have x plus 11/4 squared equals 1/16. And now I'm at the square root property. We're solving for x. So take the square root of this side, square root of that side, cancels out, this falls out, x plus 11/4 plus minus. Now remember, when you have a fraction, it's the square root of 1 over the square root of 16. These are both perfect squares, so it becomes 1/4. Okay, and then the final answer, x is equal to, subtract away the 11/4 plus minus 1/4. Two solutions are x equals 11/4 plus 1/4. This is a negative 10/4, which is what, guys? I think that's 2.5. Yep, negative 2.5. And then here, x equals negative 11/4 minus 1/4, negative 12/4, which is negative 3. Okay, so again, these are my two x-intercepts, and if you want to check it, you go back to the original problem, which is this guy right here, and then we graph it, and let's see if those are my x-intercepts. Okay, I hope I did that right. Yeah, I did. Okay. So we're looking for, let's just do it real quick. So I'm going to go back to y equals, clear this out, and do 2x squared plus 11x plus 15. Graph. And if you can see it, because again, see, it looks real nice and neat, but I do see that it falls in between some of these constant points, like I do see decimals, but just to make sure, go to second table, and as you scroll through this, let's see, there's the one that's at negative 30. You see, there's the one that's at negative 30, which again, back to this, that's what we got for this guy. But this negative 2.5, the reason why you don't see it on the calculator is because, as you can see, our x's are by ones. You know, so if you change your x scale to like 0.5, then you would see the negative 2.5. But again, we did it right. Okay, so this concludes this video because it's pretty long. Again, you know, just skip through what you don't want to hear and go from there. I'm still out of town, so it's a little noisy, so I'm sorry about that. But I hope this makes sense. Good luck to you on Tuesday. And again, I posted the solutions in your email. I will quickly upload this and send this through the email, and I'll see you guys Tuesday.